starting math workshop rotation 3, so let's make sure you're in the right spot. Landon, Genevieve, Kate, and Alexandra, you guys should get at your seats. Perfect. Tegan, Justice, Anna, and Natalia, you guys should be at hands-on. Got it? Issa, Greer, Andres, Ryan, and Madison, you guys should be at teacher's choice. Here you guys are. And then Maddie, Bella Jean, Irish, John, and Gray are at math facts. Perfect. All right, so when we get started with math workshop, remind me some of the expectations. What are some of the expectations for math workshops? Justice?
Be quiet for others.
Work quietly for others. Good. Tegan?
Not to ask you because you're working with the others.
So if you can't ask me for help, who can you ask? Anna?
You can ask people at your table or people that have done that.
Try to ask people at your table, and if they can't help you, look for someone that's already completed your activity. Good. Issa, something else.
If you finish, you can play on your iPad.
Yes. What do we do if we finish early, Bella?
We play on our iPad or we double check our work.
Please double check your work, and then you may move on to iPad apps. Can I do anything on the iPad, Genevieve?
No.
What do I need to be focusing on when I'm on my iPad, Greer?
Just play
Math games. So our math games is what we're looking for, right, Landon? Okay. Yes, ma'am.
So you can also use Math.
Please use Math Talk. What do I mean by Math Talk, or what do you mean by Math Talk? Yes, use your little sentence starters here. Is it okay to talk about the soccer game we're going to have this week? No. Okay, so keep it focused. Who is the leader for your table? Who is the leader for your table? Ryan?
The person in the top left corner.
The person in the top left corner. So if you're a leader for your group, would you raise your hand so I know you know who you are? There we go. Okay, so I made a few changes for yesterday based on the feedback I got, Bella. One, Maddie, for math facts, the leader is going to be the person that passes out the math fact quizzes. So when you are over there, I want you to pass them out for your group, and then they'll go from there. If you are adding a sticker, so can you open up the iPad case for me, Maddie? The stickers are in the bottom, just as they were yesterday. Can you remember today, if you're going to math facts, to put your initials on them so that when you give them to me, I know who they belong to? Remember, you're going to give me the sticker here. Why are you not going to hand it to me? Natalia?
Because you're in the middle of working.
I'm working with a group, so you need to put it in here. Okay, any other questions? Let's see, anything yesterday that you want to add, that advice for the people that are going to your station? Genevieve?
At the math facts, remember to not do timer because I accidentally clicked timer when I was timing myself instead of stopwatch.
Okay, but remember we've already taken the fact quizzes, so today they're just gluing them in. But you mean from previous, or are you talking about for baseball multiplication? From previous. Okay, Issa.
For hands-on, it's probably easier to hole punch them one at a time instead of all at once.
Okay, so there's a piece of advice for you if you're going to hands-on, hole punch one at a time. How many brads may you take?
One.
One. Okay, only one. They're not a toy. What else?
At your seat, you really pay close attention because some of the
Hopefully they're all paying close attention, right? But yes, especially at your seat. Okay, one more thing, then we're gonna get started. Natalia?
At teacher's choice, pay attention to the other formula she gives you because it's helpful.
Good. Good. Okay, Joe.
At your seat is hard.
At your seat is difficult, but who can you get help from if you need it?
Classmates.
Use your classmates to help you. Good. All right, we're gonna get started. So if you will start, Maddie, get your things for your people over there. Hands on, you may go and get what you need. At your seat, get your math journals out, and you guys need your dry erase marker, dry eraser, and dry erase board. Can you just share? Okay. gonna give you a few seconds to get your materials and then get settled. You guys ready? Hands on, you ready? Good? Okay. Alright, you guys, here we go. We're gonna start with mental math. So all these that I'm giving you, I want you to do in your head and then just write the answer only on your dry erase board. You ready? Here's your first one. So do it in your head, give me answer only. Good, 16. Here we go, do another one. Good. 22. Alright, next one. Good. Alright, look at these three equations. What do you notice is the same or different about them? Andres, tell me what's not the same or different.
They're all 4, 6, and 2.
They all use the same numbers. Good. Something else that you notice, Madison. Okay, that's a good observation. All the answers are even. What else, Brian? Yeah, so we have the same number, so how is it that we're getting different answers? If they're all the same number, Ryan, how are we getting different answers?
Maybe because of how you're adding or subtracting or dividing.
Exactly, and so what do we call that? Where we have to add or subtract or multiply or divide in different ways. Do you know, Isa?
Like order of operations.
We're using our order of operations. Okay. So here we were multiplying and subtracting, and we're using our order of operations. We're getting different answers. All right, erase your boards. Here's the next one. Positive thoughts. You don't have this problem, right? All right, here we go. Here's your next one. Good, mental math. Good. All right, next one.
Yeah.
All right, so let's take a look at these two problems. What do you notice is the same about these problems? Andres again.
So they're like all. I noticed 3 things. They're all in the same order. Like
Okay.
they're all in the same order. They're all the same numbers, and they got the same answer.
So wait a minute, how is that possible? Because last time we used all the same numbers and we all got different answers. So why is it that we're getting the same answer this time, Ryan?
Because it's all multiplication.
So why does that matter?
Well, because if it's different, it will get a different answer. So
What
if
do you
it
mean
was
if it's
multiplication with the same numbers, it would all equal the same.
Okay, so think about how we use multiplication in finding volume, Madison, and in finding area. How does this relate to using those formulas for finding volume and area? Can you see how that would relate to what we're doing with volume and area and why this would matter? Some of you are too loud. I'm gonna tell you. Okay, what does that help us see? Can you see? Do you want some help? Okay, can you help her? Lisa?
It could be like 10 is the length, 4 is the width, and 2 is the height. And then, but you have to do length and breadth and height, so they're all multiplied.
So any order, if we can multiply them in any order, we're gonna still get the same answer. And that's the same when we're finding volume or area. We can multiply them in any order and still get the same area. So still get the same area or the same volume. Okay, let's move on. This one is challenging, but again, mental math, so try to do it in your head. Let's see how you do.
Yeah, improved by 6
Close. All right, 12 times 2 is?
24.
24. Those of you that got the answer already, tell me what did you do now that you have 24 and 48? Ryan, what
Well,
strategy
you,
did you
you
use?
could just do the first number is 2, and then you add those together, and then you could do 8
8 plus. Wait, it was 4. So
Uh-huh.
it would be 12. So you don't need the 1. You just need the 2.
So instead of trying to column addition, do the tens first and then the ones next. And so we should have gotten 72. Okay, erase. One more step. Here we go. All right. A little bit more challenging. Okay, good. Division.
Guys, if we miss 2 of the same problem, you
Okay,
only
6
write 1.
times 5 is 30 times 2 is 60. 60 divided by 5 is
12.
Good. Okay, here's the next one. Adding in more parentheses,
56.
more operations. Work it with me. Andres, 15 times 2 is
15 times 2 is 30.
30. 6 times 5 is
40. No, wait, no, not 40. 30.
30. 30 divided by 30 is
30 divided by 30 is 1.
there you go. Okay, last one. Good. 9. All right, would you please put your dry erase board away, and would you, I'll normally have you join me here, but Miss Wagner, we're not gonna move you, we're gonna leave you right there. So you'll be fine. All right, you guys. So you this week, I'll go ahead and give you time. Andres, put that away, darling. Will you bring your crates up here? Oh, just set it on top. And you can put it away in a second. There you go. Greer, you may want to come over here, just because my back is going to be too. Okay, table leaders, make sure you're keeping your volume down for your tables, please. Landon, help us out. Keep your table volume down. Okay, here we go. Ready, guys? So this past 2 weeks, we've been learning about area and volume. Give me something that you learned about area. What have you learned or remember about area? Ryan.
It's the amount of cube. Well, no, that's fine. It's the inside of the. How much cube it is, but I don't know.
I know that part is
Anything you know about area? Bella? What do you remember? Area. Oh, area. Gotta think back 2 weeks.
It's the amount of space in a two-dimensional shape.
Okay, there we go. It's the amount of space in a 2D object. What is a two-dimensional object, Andres?
Two-dimensional object is that it's flat.
It's flat. Good. Okay, give me something else you know about area. Close the book. Give me something else you know. Isa.
Length times width is the formula to find it.
Length times width is the formula for finding area of a rectangle, correct? Because is it different for a triangle?
Yes.
Yes.
You have to divide it by 2.
Good. Okay, so it's length times width. What else can you count? Anything else? Madison, what is area measured in? What kind of units? Square units. There we go. Okay, tell me now what you remember about volume. Give me something that you remember about volume. Andres,
The amount of space an object takes up.
what kind of object?
Cube. Or
If area is dealing with a two-dimensional object,
oh,
what is
in a three-dimensional shape.
three-dimensional shape? Okay, what else can you tell me, right?
Length times width times height.
What about length times width times height?
Well, that's the formula.
That's the formula for finding volume. Good, what else can you tell me?
You could also do base times height with a capital B.
Okay, tell me why.
Because I just know with the capital B, I'm not sure why, but I know that you can do base times.
Where have you heard capital B before?
I think last year we kind of talked about it.
Okay, good, because that's exactly what we're going to talk about today, is what is that second formula for finding volume. Okay, tell me, Andres, let me have your attention. Where, what are we gonna measure volume in? If area is measured in square units, what is volume measured in? Cubic units, there we go, we represent that with that little 3, right? Okay, so what do you notice is the same between these two formulas? Madison, give me something you see that's the same about those two formulas. Yeah, look, do you notice that they both have length times width in them? Right, so if I'm looking at this rectangular prism, right, why can't we call this a rectangle? Why can't we call this a rectangle?
Three-dimensional.
It's three-dimensional, right? It has height. We can't call it a rectangle, we call it rectangular prism. But what do you notice about the base of this rectangular prism? What shape is that base, Ryan?
Well, it's kind of a flat rectangle.
It is, it's a rectangle, right? And so when we're finding volume, when you guys are stacking your prisms, you found how much space or how many cubes or how many pattern blocks fit on that bottom, and then you multiplied it by how high it was, correct? So you were actually finding the area of the base. You're finding the area of that rectangle there on the bottom. And so another formula we can use for finding volume is we can use what you said is the capital B, which represents the area of the base, the area of the base. And so, do you remember when we used another formula for here and we would do base times height, and I always said use a lowercase b? Well, this is why, because this capital B represents two dimensions, right? Length and width. It's that area of the base. Does that make sense to you guys? Okay, so we're gonna look at some examples of when would we use this and when would we use this? And would we get the same answer? What do you guys think? Do you think we're gonna get the same answer if we use this formula or this formula? We should, right? Because this is that. Does that make sense? Okay, so would you open up your math journal to page 25? Open up your math journal to 25. You should see these two shapes at the top. Are these two rectangular prisms? Alright, take a look at number 1. If I look at that, which formula do you think I would use based on what I'm seeing, based on my picture? What formula do you think I would use? Andres, what do you think?
Base times width times height.
Length times width times height.
Yeah.
Why would you use that one?
Because there's at the so there's squares at the bottom on the sides and height. It's three-dimensional.
Good, it's three-dimensional. We see all 3 dimensions represented there, correct? Okay, so on the formula, would you write V equals length times width times height? Okay, so what is the length of our rectangular prism? What length do you see, Ryan?
5.
Okay, are you going this way?
Oh, yes. And,
Okay,
well, I'm
that's fine.
doing it at the bottom too.
Okay, good. And then what is your width then, Isa? 8. And then what is my height? Maddie, what is my height? Madison? 4. Okay. What if I called this my length and said that was 8? Would that be okay? Would I still get the same answer? What do you think, Andres? Would I? If I called this right here my length instead, would I still get the same answer? Yeah, remember that when our math message, our warm-up, when we reverse those numbers, we still got the same answer. Okay, so let's multiply that. So we're gonna rewrite that formula. We're gonna now add these numbers in for those letters. So those letters are called variables. We're gonna add the numbers to represent those variables. Okay, so let's do some multiplication. 8 times 5 is?
40.
40 times 4?
160.
160. But can I just leave it at 160? Can I? No, turn to your neighbor and tell, what am I missing? What am I missing, Greer? Unit squared? How many of you guys agree with Greer? Unit squared? What is it? Cubic units. Why is it units 3 or units to the 3rd power or cubic units? Because we're measuring in 3 dimensions. Good, good, yes. Alright, so let's look at this example here. Looking at our 2 formulas, which formula would you use to solve for number 2? Read that, let's look at that. Which formula, Ryan?
Base times height.
Is it base times height?
Oh.
Remember, it's a B, but remember that's the area of the base times height. Okay, area of the base times the height. So that's that bottom layer there. Why would you choose to use that formula?
Well, because it doesn't have like this square which only has 3 lines. It has the whole base covered and just the height.
Exactly, so the whole base is covered. So there's 2 strategies we can use. We can sit here and count all of those cubes, or we can figure out length and width and multiply them together. So when you count them, or when you multiply length times width, what do you get, Andres? What is our base?
It's our base is
So if I sat here and counted all these, how many would be there?
15.
Keep going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
Well, I was going by 5. I was just on the way up.
Yep, you're 1 away. So how many are there? 20. And then what is the height of our prism? Madison? 4. Okay, so if I multiply those together, Kate, let's get busy. What would I get? Say it. 80, and what am I missing?
Unit 30.
Units cubed, we say. Units cubed. Okay, put your pencil inside of your book and close your book. Okay, we're gonna look at these examples with me really quickly. Here, we're missing the cubes. Now we just have numbers. So if I'm looking at this, what formula would you use to solve this one right here, Isa? Right, I have length, I have width, I have height, so it makes sense to use that. Okay, what about this one, Andres? Which one would you use?
Yeah, length and width.
Length and width.
Because they're height.
Okay, so look down here at this example. Greer, which one would you use? Which formula would you use for that one? Area of base times height. Do you notice that this blue is shaded in? Why do you think the blue is shaded in there, Brian?
Sure. Well, that represents the base,
That
so they don't have
represents-
to drop cubes.
Exactly, it represents that whole area down there at the bottom. Why does this centimeters have a 2 or a square unit right there, Lisa?
Because it's the area of it, so it's like 2 dimensions.
Exactly. Would this still be cubic units when we get our answer? Yes, it would be. Andres, would this still be cubic units when we get our answer? Yes, it would be. Okay, in the science lab on Friday, do you remember when we filled the prism A, B, and C up with cubes, and then we figured out that A was 24 cubic units? And I said, give me another way to find 24. Okay, here you're gonna do that same thing, but your number is 36 cubic units. So you're gonna give me 2 other ways, or 2 ways I can make 36 cubic units. Okay, so think about what we did in the science lab on Friday where we filled the prism. Now you're gonna come up with 2 ways that we could, 2 different dimensions that we could get 36 cubic units. Alright, so I'm gonna let you work on this for about the next 4 or 5 minutes, and then we'll check our answers in just a second. So open up. Somebody here put one in, 2 people here put one in without an initial. So if you wrote with red,
Is it in red?
put your initials on it and I'll put it back in here, please. Go get it. You still typing it? You guys have 3 minutes to finish the station you're at. 3 minutes.
Maddie, go on to do page 30.
Let me see what you came up with. Yes, would you work on page 30 while you wait for your friends? Girls good? Well? Okay, if I multiply all those together, am I gonna get 36?
Oh no, I found my password.
What happens if you multiply all those together? Because remember, volume is linked with this height. Would I get 36 if I did 12 times 11 times 12? 12 times 1 is 12, but what's 12 times 12? Not 36. Okay, now look at your second one. Good, I like the way you wrote it really quick. Alright, let's take a look at your answers together. So here, you guys told me we would use length times width times height. We got 72 cubic centimeters. Here, again, length times width times height, 90 cubic units. Here, we did area of base times height, which is 50 cubic centimeters. And then here are some sample answers. I saw some different ones from you. Ryan was giggling because he came up with a funny one. Which one, Ryan?
36 times 1 times 1.
But does that work? Yes. Okay, can you think of another one that maybe is not up here, Andres?
3 times 2 times 12.
Let's see, 3 times 2 times 12. What do you guys think? 3 times 2 is?
Oh, wait, no.
A little too much.
Yeah.
Can you work on that? We'll come back to you. Okay, Madison, let's hear yours. What about your second one?
2 times 3 times 6.
What do you guys think about that? 2 times 3 times 6? Does that work? Yes? Okay, did you fix it on
3
this?
times 1 times 12.
3 times 1 times 12. What do you guys think? Yes. All right. Good. All right, we're gonna stop here for today. If you'll clean up, and then we're gonna rotate.
No.
All right. Would you stop what you're doing and clean up? And when you're ready to rotate, stand behind your chair. Oh, but I fixed it. There you go.
You have those buttons that say like.
Do we have to retry if we lose?
You should.
No, but what if we don't like get anything wrong and they're just
I'm not sure I understand your question.
well, sometimes it just says you're out.
Oh yeah, like it just. Oh yeah,
Answer question correctly and it randomly just says you're out.
Sometimes it does that to speed the game along. If you're winning a lot, I think. Is that what you've noticed, Iris? About my station? All right, would you rotate to station 4? Rotation 4. John, Iris, it's time to rotate. Ask a friend for help. Ray, you're going to need a dry erase marker and eraser. John, let's go. I need you moving. Maddie, you need a dry erase board and a marker. I do all your work first. Dry erase board and dry erase marker.
Is there supposed to be a thing of Claire Paris in there? And
Come on, we're about to get started. I'll need you here.
in here?
Yes? But right now, what should you be worried about? Cleaning up and moving on. Put your iPad away and come join us.
John.
You need your dry erase board and dry erase marker. What's wrong, Maddie? You need one? You can use this.
That's right.
Here you go.
That's right.
Okay, you can use that.
Oh, you can?
You can. All right, we're gonna go ahead and get started. John, I need you to join us. Maddie, would you move your stuff over here because we're gonna use that table in a second. Bella Jane, just put your math journal right here for a second. Out of the way. Just put it right here. Right here. I don't want it on the ground. Thank you, ma'am. John, put your purple binder over there in your tab after you get your dry erase marker. All right, we're gonna go ahead and get started. Here we go. Give me the rules for using dry erase board before we start, Bella. Only write when your teacher tells you to write. What else, Greg? No doodling. What else? Iris, what else? Anything else we need to remember?
I almost embarrassed.
How should we write? Write big so at least teacher eyes can see it. And what else, Maddie? Neatly? I'm only asking you to write a few things, so can you make it neat, please? All right, the rest of you should be settled now. Team leaders, make sure you're keeping your team focused and on task. John, do you have a dry erase board? Where's your dry erase board at? Here, I'm gonna give you this one to use.
I thought you said dry erase marker.
Yeah, but you have to have something to write on there. All right, here we go. All right, so this we're gonna do, still waiting for a couple of tables to get settled. Okay, we're gonna start with some mental math. Mental meaning I want it to be done in your head. Here we go. There's your first one. On, there's your first one.
Oh, no, we're
Want
not
the
doing
answer, write it.
Oh, okay.
Good, you should have gotten 16. Here we go, there's the next one. This binder is gonna be a repeat, so, okay. There you go. Good. There you go, 22. Here we go, here's the next one. Good. Good. Tell me something you notice the same that's about these. What do you notice that's the same about these problems, Joan?
No, even.
They're even answers. What else do you notice, Maddie? We are using all the same numbers. What else do you notice, Bella Jean?
All the same things except brackets are in different places and all the seven.
Okay, good. So we see parentheses in different places. We see that there's some subtraction. We see multiplication. Please stop playing with that. What else do you notice, John?
There's parentheses in each column.
There are parentheses in each problem. So why, if we are using the same numbers, why, Iris, do we get different answers?
Because when you change the parentheses, it changes what you do first.
Good. And what do we call that in math? Order of operations. Good. All right, so erase your board. Here's the next one. And I was being a little stubborn earlier. Let's see if it'll move faster now. And it won't. Think good thoughts. Think good thoughts. You know what? I think I'm just gonna give it time to think. Here we go. Here's your next one. John, you only need one eraser because that other one will float away. Here we go. There's your next one. Good. You should have gotten, let's look, 10 times 4 is 40 times 2. 4 times 2 is 8. Add that 0, 80. Okay, next one. Landon, are we keeping our math talk neatness, please? Still waiting. 4 times 2 is 8. 8 times 10 is 80. Look at these two problems. What do you notice is the same about these, John?
both equal 80.
They both equal 80. So how is that the case when last time we had the same numbers in our equation, but the answers were different?
Because it used multiplication, like it isn't. So like, let's say in the last time in the parentheses, there was like a times in the parentheses and a minus for parentheses, and then out of the parentheses, and then like in the next column down, there's a times not in parentheses, and there's a minus in parentheses.
Correct. So this one we're all using just multiplications, correct? Is that what you were gonna say? You guys keep your talk focused on that. Great. Yeah, John, that's a good observation. Last time we had subtraction and multiplication, but this one is only multiplication. So what does that tell you about when we're multiplying? Can we move those numbers around and still get the same answer? I believe so. You should believe so. That is correct. Okay, look at this one, please. A little bit more challenging. Again, mental math. See if you can do it in your head. Close. Keep trying. There you go. Good. Keep trying. There you go. What do you have? 8 and 4. Okay, let's look at it together. 12 times 2 is 24. John, you came up with that answer very quickly. Tell the girls what strategy you used to get that quickly.
I looked at the parentheses first and saw 12 times 2 equals 24, and then I added 4 plus 8, and then I added 15 big numbers.
So instead of doing that column addition, you're working with the tens and then the ones and putting those groups together. Okay, do you guys see how he used that? All right, here we go. Let's look at this next one, Bella Jean. Sending good thoughts our computer's way.
You could try making it stop load and then refreshing it.
I could. I'm just gonna give it time to think, just like we need time to think sometimes. See? There it goes. All right, there you go. A little bit more challenging.
I'm cutting all mine.
There you go. You guys got it. 12. Okay, try this one. Adding in more operations, more parentheses. Look again, Greg. Look again, Maddie. Look again, Bella Jean. Let's do this together. What's 15 times 2? 30. 5 times 6? 30 divided by 30. 1. There we go. Last one.
Decade, century, millennium. 5 decades, century, millennium. Like periods of time.
Look again. Yeah. Look again. There we go. 21 divided by 7, Maddie. 3. 36 divided by 6, John.
It's 6.
3 plus 6 is
9.
9. That's what we were looking for. Would you put your dry erase boards and markers away, and would you join me around the dry erase board up here? So you two, John and Maddie, can stay there. If you three want to move your crates over. Oh, careful. Are you all right? Are you okay? It's okay. Good, Iris, thank you. Yes, ma'am. Bella Jane, let's see, I just gave you 2 directions. Put your dry erase marker away, put your dry eraser away, and move up here to the board. have to get with you in just a minute so you can tell me what you're explaining, because I don't think I'm understanding it. Let me move on and then I'll come back to you, okay? John, I've asked you to put that away. Put your dry erase board away right behind you on the bottom shelf. And then put your eraser and your marker in the middle.
Oh, there.
Okay. Tell me what you guys remember about area and volume from the past 2 weeks. Give me something you know. Gray, what do you remember?
The formula for volume is length times width.
Is there paper here?
Okay.
Also,
We'll give you one thing so we can have, so I can hear from others too. So that's the formula for finding volume. Okay, what else do you know, Maddie?
parallel measuring two-dimensional.
Say it again.
Two-dimensional
For which one?
for area.
Area, we're measuring two-dimensional. John, what does two-dimensional mean?
That means like it's one side of a 3D.
So what is it?
It's just flat.
It's a flat shape. Good, okay, what else can you tell me?
We've been measuring three-dimensional shapes with cubes.
We have it. And what are we measuring with cubes? What, are we measuring area or volume?
Both?
With cubes?
Both.
We're measuring three-dimensional shapes. We're trying to find its volume. What else can you tell me? Gray?
With area, you use square unit.
Good, yeah.
And volume is units cubed.
Good. What else, Iris, can you tell me? Anything we're missing from up there? So we know area is finding is working with two-dimensional shapes. Volume is three-dimensional. What else?
On area, like it has to be like flat.
Okay, good. I think John said that. Can you give me something else? What is area?
Area is the amount of space inside of shape.
Okay, in real life, where would we find area? Can you think of some place in real life where we would even, that would be important too? Why would we be finding area of our backyard? What would we be doing in our backyard that we need to know area? Can you think of some reason why we would wanna know how much space is in our backyard?
Making the garden.
Okay, maybe if we're gonna make a garden, good. Okay, you wanna add something to that?
Cool.
Yeah, if we're gonna find how much space in our backyard, for our pool, right? Are we also finding volume for the pool though? Doing how, like if we're gonna figure out how much water it's gonna hold and that kind of thing, good. Can you think of another?
The formula for area is space times height.
Yes, sometimes we say base times height for formula for area. Is there any other formula we use for, finding area, Belladine? Sometimes we say base times height, and this is for rectangles. Sometimes we say length times width. Good. What are we finding when we're finding volume? So you said for area, we're finding the inside of a 2D object, but what are we finding when we're finding volume? Iris asked
How much
it.
space something takes up.
Okay, good. Alright, do you look at these two formulas for area and volume? Do you see anything that's similar with those two? What do you see that's the same? For the two formulas, for the formula for finding area of a rectangle and the formula for finding volume.
Well, what if I said the length? Wait, the base is the bottom. The bottom.
Okay, yes.
Wait,
basis.
length times. Wait, it's kind of the same. It tells how much the base.
Okay, I think you may have heard me say something before and you're trying to make that connection right now. So you're saying like the area is the base of a rectangular prism, is that what you're trying to say? Am I hearing you correctly?
Yeah.
Yes, okay, Maddie?
You're multiplying it by 2,
What does that mean?
the measurements 2 times. But then
Okay,
you're also measuring one thing for volume, but you're measuring the width.
okay, so I'm measuring 2 things for area and I'm measuring 3 things for volume. Do you see anything similar that I'm measuring for area and volume? I see you.
The length and the height.
Length and the height, I see length here, but I don't see height here. Okay, I see length and width, and I see length and width. Is that what you guys were gonna say?
No, I have something different.
Something different, Bella Jean?
They're both using multiplication.
They are both using multiplication. What else? Iris?
On volume, you're also doing times height. Because
Yes.
something that has volume, well, like, you'll have to measure how tall it is, but if you're finding area, it has to be flat, so it's like, it doesn't have any depth.
It doesn't, good, very good. Yes. So we notice that here, if we're looking at this rectangular prism, right? Why can't I call this a rectangle? Gray, why can't I call this a rectangle?
Because it's a rectangular prism and it's 3D and all.
Because that has that 3 dimension, right? That height. If you look at the bottom of this rectangular prism, what do you notice? What shape is that, John?
Rectangle.
It's a rectangle, right? And so remember when you guys were stacking cubes the other day in our rectangular prisms, and some of you stacked just the bottom, and then you counted, and then you said, oh, I'm gonna just see how high it goes, and I'm gonna multiply that. Well, you are actually using our second formula. So there's another formula you can use to find volume, and we call that capital B times H. Now, capital B represents the area of the base. So if I were to stack the cubes along the bottom up here and then figure out how many fit on the bottom layer, I'm really finding the area of the base. And so that's why we call it area of base times height. So many of you were doing that before you even knew you were doing that.
So the base is length times width.
Exactly. The area of the base is length times width, and we're gonna see how and when we would use each of these formulas in just a second. Okay? Would you go back to your table and turn to page 25? Iris, we don't sit on it that way. Go back to your table and turn to page 25, please. You should see these two examples right here. On your bottom, Miss Bella. John, you need a pencil. You have a pencil out? Good for you. Alright, just waiting on the girls. Page 25. Okay, if I'm looking at this first rectangular prism, which formula do you think I would use if I want to find the volume of that shape? Look at it carefully. Think about the two formulas we have for finding volume. Which one do you think? Turn to your neighbor and tell them which one you think you would use to find the volume of rectangular prism
I would
one.
go with this, down like 1, 2, 3.
So we've learned two formulas. Which one of these would you use?
I'll use base times size.
Okay, what did you think, Bella? Which one would you use? Okay, explain to your friends why you think you would use that one.
Well, because as we were talking about here, that if you're finding volume, it's for a 3D-dimensional shape.
Okay.
If you're finding area, it's for a 2D dimensional.
Okay, so this is a formula for finding volume, so we want to use length times width times height. Why would you use this one versus the area of base times height? Iris?
Because then it like already shows you everything you need to know. You don't need to know how many filled holes at the bottom.
Exactly, so here I see there's the length, there's the width, there's the height. I just need to count those three up and multiply them together. So would you do that and tell me, what did you come up with for length